Alright, the shape of a ski ramp is defined by the function h of x is equal to 0.01 x cubed minus 0.3 x squared plus 60 on the interval of x is greater or equal to 0 and less than or equal to 22. Find the interval as a concavity for the given interval and find the steepest point on the ski ramp. Okay, so to find the interval as a concavity, we need to find our second derivative. So I'm going to start by finding my first derivative, h prime of x, is the derivative of 0.01 x cubed minus 0.3 x squared plus 60, right? In this case, you're going to get 0.03 x squared minus 0.6 x. Okay, so that's your first derivative. The second derivative is the derivative of this guy, which is basically 0.03 x squared minus 0.6 x, which is 0.06x minus 0.6. Okay, so that's your second derivative. This is h double prime of x, and you want to find the interval as a concavity for the given interval. Okay, so to find the interval as a concavity, let's find the point of inflection. So the point of inflection occurs when the second derivative function is equal to 0. So 0.06x minus 0.6 is equal to 0. I'm going to move the 0.6 to the other side. 0.06x is equal to 0.6. I'm going to divide this by 0.06. I'm going to do the same thing here. X is equal to 10. Okay, so x is equal to 10. That's basically when you have a point of inflection. And basically, we can find the interval of concavity based on this, right? So we know that the interval that we have to look at is 0 and 22, right? So when I'm looking at my interval of concavity, I'm going to use my point of inflection. I'm going to create a number line just to kind of demonstrate this. Okay, so let's say that this is 10. Okay, so this point is 10, it's non-inclusive, this is 0, right? We shouldn't have an arrow key here. Maybe we should just have, so let's just do it as a number line. So this is 0 and this is 22, right? So I want to look at the value between 0 and 10. So if I'm looking at the value between 0 and 10, let's say x is equal to 5. Okay, so I'm going to do h double prime of 5. If I plug that in, you get 0.06 times 5 minus 0.6, right? So in this case, we're going to get here, if I multiply this, if I plug this in my calculator, right, h double prime of 5 is going to be less than 0 because it actually gives me negative 0.3, right? So this portion here is concave down. Right, now between 10 and 22, let's say x is equal to 15, I'm going to do h double prime of 15 here, which is 0.06 times 15 minus 0.6, and that's going to give me positive 0.3, so 0.3, so h double prime of 15 is greater than 0, so this is going to be concave up, right? So we're basically referring back to the second derivative test, right? H double prime of x, if it's less than 0, it's concave down. If h double prime of x is greater than 0, it's concave up. Okay, we have a point of inflection at 10, right? Specifically, if you wanted to figure out the actual point, it's going to be 10 and h of 10. And h of 10, if you plug this into your function, 0.0110 cubed minus 0.3 times 10 squared plus 60, if I plug that in, I'll get 40. So h of 10 is equal to 40, right? So we found our point of inflection as well, so it's 10 and 40. So we have our intervals of concavity, right? So it's concave up between the intervals of 10 and 22. I'm going to say x belongs to 10 and 22, right? These are supposed to be round brackets, right? So it's non-inclusive, right? And it's going to be concave down. Oh, what happened there? Let's just put that back. Okay, so it's concave down in the interval between 0 and 10. Okay, so that's what we can see from our number line. Now we want to find the steepest point on the ski ramp. The steepest point on the ski ramp has to have the highest slope, right? And the steepest point of the ski ramp actually occurs at the point of inflection, right? Because the second derivative is equal to 0, right? And that actually represents a maximum of our first derivative. So the steepest point on our ski ramp here is actually the point of inflection. Represents the steepest point on our ski ramp. And this basically is the point 10 and 40, right? So if we look at our points here, x is basically the horizontal distance, h is the height, so it's basically a horizontal distance of 10 meters and the height of 40 meters. So this is going to be our steepest point of our ski ramp. So this is how you can use the second derivative, right? But also the second derivative, the point of inflection also represents a maximum point of the rate of change, right? Because it is a maximum, it represents a maximum or critical point of your first derivative function. That's really important to understand as well.